What's going on, guys? Today I'm going to be solving and giving solutions for how you do maximum depth of a binary tree. It's part of the blind 75, and it's a pretty good question. So yeah, I just wanted to give my solution to it, or I guess the solution to it. I'm going to be doing this in both Java and Python. So if you want to see the Python one, I'll have it on my channel as well. But anyways, so we're going to be going through two solutions to this. So we're going to be going through a recursive depth first search and an iterative breadth first search. Yeah, but so anyways, so let's get into it. So first things first, for the recursive depth first search, we're going to want the base case, which in this case is when whatever we pass is null, which makes sense because if there is no node, how can it have a level? So we should return 0. Otherwise, what we're going to want to do is say int left equals 1 plus the max depth root dot left. Okay, and then int right equals 1 plus the max depth root dot right. Okay, and then so after this is done doing all the searches in a depth first search fashion, the left integer will equal the maximum depth on the left side, and the right integer will equal the maximum depth on the right side. Okay, thus we want to return the greater because that will equal what the maximum depth is. And to do that in Java, you can just use this kind of built-in feature. It's math dot max left right. And yeah, so I'll just kind of quickly run through how it works. So what we do is we start with the root. In this case, it's not equal to null, so we then set left to 1 plus, call it again with this. Okay, this is not equal to null, so we call it again with 1 plus this. This is equal to null, so 1, 1, and then go back to this, go back up here. This is now going to be set to 2. We then call it again with this, start again, not equal to 0. So then start again, go here, boom, boom, go back up, 20, then go right, 0, 0. Okay, so this is going to return 1. This is going to return 1. This is going to return 1. Then we're all the way, once we're all the way back up at the top, int left equals 2, and int right equals 1. Sorry, equals 3. Turn the max, which is the right, 3. And that's exactly what we get. Just a minute just to kind of show that it works with all the tests. And yes, okay. Anyways, now let's get into the iterative breadth first search. So in a depth first search, what you do is you start at 3 and then you go to 9 and then you go all the way down and you keep searching until you can't search anymore, and then you work your way back up. Okay, but with an iterative, or just with breadth first search in general, what you do is you start at your starting point and then you check all the ones that it's attached to. So here we do 3 and then we go 9 and then we go 20. And let's say that 9 had children like like 1 and 2. Let's say it had like 1 and 2, right? In a recursive depth first search, we would go 3, 9, and then we go 1, and then we go back to 2, and then we go back up. But in a breadth first search, we go 3, 9. Doesn't matter if it has children. We then go to the next one that 3's connect to, which is 20. Okay. And yeah, so that's just kind of the differences between a depth first search and a breadth first search. But yeah, so anyway, so I can do the same thing just in case there is nothing, like the tree is empty. So say if equals null, return 0. otherwise. And oh yeah, so basically a really good way to do, or like kind of the best way to do iterative breadth first search on trees is by using a queue. And so I'll show you guys how to do that. So what you want to do is, actually we'll start off, we'll just make an integer level. We'll use this to keep track of which level we're on, and we can go ahead and just, I'll show that ultimately that's what we're going to be returning. Okay, so then we're going to make a queue, and our queue is going to store tree node objects. So we'll put that there. And call this my queue equals new linked list. Then go ahead and go my queue dot add. Go and add the root. Okay. Now, usually, pretty much always when you're using a queue, you want to use a while loop. And so we'll go my queue dot is empty. And I'll say it's not empty. So we're basically just going to loop through while the queue is not empty. Okay. Then we'll say int size equals my queue dot size. This is really important. If you don't have this, you won't be able to tell if you're on a new level or not. Okay. So when you're doing an iterative search through the tree, if it doesn't matter like what level you're on, or if you need to know what level you're on, then you don't need a for loop. But if you do need to know, like we do in our case, then you need a for loop. And you always want to set the for loop equal to the size on this iteration. Yeah, so anyway, so then just go for I equals 0, I is less than the size, go stop I plus plus, boom. Okay, now I'll go tree node temp equals my queue dot remove. We'll then check if the temp dot left is not equal to null, in which case we want to add it to our queue. Dot add temp dot left, and then do the same with the right. Go my queue dot add temp dot right. Okay, and then we know that we're on a new level every time that this for loop gets executed. So in this case, we want to increase level. Okay, so let me just explain. So let's say we have my queue, and this is the queue. So queues are, oops, hold on, let me just take this. So what are queues? So queues are a first in, first out. First in, first out. Okay, so you think of it like a line. So the first person to enter a line to a store is going to be the first person to enter the store. The last person to enter is going to be the last person. Okay, so let's think about in this example. So first thing we do is we add the root. So we add 3, okay? We then check the size. The size is 1, okay? So this is going to execute only one time. We're going to increase our level by 1, okay? So what are we going to do next? We're going to do this one time, okay? So we'll take the temp left, it's not equal to null, it's 9. Right is not equal to null, 20. We're going to add, and also remember, we actually removed 3, okay? So we're going to add 9, and we're going to add 20, okay? And then going to go back up. We're now on a new level because we exited the for loop. So we need to increase this by 1 again. So now this is 2. So we can think like level is 2. Okay, so then again, we're going to set this size equal to how many are in here. So in this case, there's 2 in here. So this is going to execute 2 times. Okay. And so we're going to remove 9. Boom, remove. We're going to check its children. Has nothing, so we're not going to add anything. We're then going to remove 20. We're going to check its children. Yep, it has 15. Add 15. Yep, it has right. Add 7. Okay. Then this finishes. We go back up to the level. Increase it by 1. We then check our size. Size is 2 again. We then remove 15. 15 doesn't have a left, doesn't have a right. Go back up, 7, remove, and then our queue is empty. We then do this, we then go up and check this, say one more time. The queue is empty, so we're not going to execute this, and then we're going to return level. And yeah. And yeah, so anyways, that's been the video. Hope you guys liked my explanation. If you have any questions, just leave them in the comments. Be happy to answer them. And yeah, have a good rest of your day.